Many believe that driving is an activity only reserved for those who can see. A blind person driving a vehicle safely and independently has been considered an impossible task. Until now. Hello, my name is Dennis Hong, and we're bringing freedom and independence to the blind by building a vehicle for the visually impaired.
Next January, preceding the Rolex 24, the first car drivable by the blind will be demonstrated at the Daytona International Speedway.
We have to build inside the machine a piece of technology that will let us perceive the exterior world. To accomplish our goal, the National Federation of the Blind will work in partnership with universities and technology manufacturers to combine our pioneering enterprise with their technical expertise to make the dream of a car drivable by the blind a reality.
In 2009, the National Federation of the Blind and Virginia Tech created the first prototype of a blind drivable vehicle.
It gives you freedom, and it really brings into reality that this could happen someday.
The blind drivable car is one of the most exciting opportunities to build new technologies to bring information to the blind that we have ever undertaken.
Wow, very exciting, isn't it? But a car for the blind? How are we going to pull this off? How would it work? What impact would it have on society? Or even would society accept such a radical idea? Well, before we try to answer these questions, let's quickly take a look at another different project called the DARPA Urban Challenge. You probably heard about the DARPA Urban Challenge. It was sponsored by DARPA, the DoD from the United States, the Department of Defense. It was all about developing a fully autonomous vehicle. It's a robotic vehicle that can drive in the urban environment. So in other words, you press start and nobody touches anything, and the car can reach its destination safely by obeying all the rules of the road, avoiding obstacles, negotiating traffic circles, and also parking. So at Virginia Tech, we formed a team. The team name was Team Victor Tango, and we developed a robotic car called Odin. Let's take a look at the competition in 2007.
The number 32, Victor Tango. It is
Odin. It's a Ford Escape hybrid.
Now look at the speed here. This is the first traffic circle, and I'm impressed with how fast that Odin's going.
That's right, and you know, again, no one is in it. Odin is driving itself.
I gotta tell you, this is absolutely fascinating to me.
That is fantastic.
Take a look on second mission already, the 32.
Virginia Tech, and they are looking
for a parking space.
Looking for parking.
And look at that.
Yeah, that's great. And out.
You know, it's just incredible to watch what's going on here. I can't overemphasize how important this is.
You hear the applause by everybody behind us.
And there, Dr. Tether waves the flag. That's an official finish.
So, how did he do? We actually placed third place and won a $500,000 cash award. And this really put Virginia Tech as one of the top 3 research universities in autonomous vehicle technology. Now, at the time, this is 2007, NFB, the National Federation of Blind, challenged the research community about who can develop a car that can be driven by the blind. They called it the Blind Driver Challenge. And we thought, hey, it sounds not too difficult. We already have a fully autonomous vehicle, right? We just yank out the drive-by-wire system, put a blind person in it, and we're done, right? Wrong. We couldn't have been more wrong. What NFB wanted was not a vehicle that can drive a person around, but they wanted a vehicle where a blind person can make active decisions and drive the vehicle. So we had to throw everything out the windows and start from scratch. At the time, a lot of people thought we were crazy. Some people still do. And as a matter of fact, myself, I think I'm crazy time to time too as well. But we decided to take this challenge. So, with just a small fund of $5,000 seed money, we put together a dream team, 12 really brilliant undergraduate students, and we decided to tackle this challenge with this one crazy idea. But where do we start? It's a car that needs to be driven by a person who cannot see. You know, so we tried to figure out how to do this. We had many meetings, brainstorming sessions. We had different inventions, success and failure. But at the end, we put together a rather impressive vehicle. Oh, by the way, we only had $5,000, right? And we needed a car. So we bought a really dirt cheap red dune buggy off eBay. And we spent $3,000 on the car itself. So our vehicle was born. The vehicle name is called David. It stands for Demonstrative Automobile for the Visually Impaired Driver. And David has become the world's very first and only vehicle that can be driven by the blind. So our first successful test was in spring 2009. So on Virginia Tech campus, we invited two gentlemen from the NFB, the National Federation of Blind, and we gave them a quick crash course of how to drive this vehicle. And in the parking lot, it was absolutely amazing. These two people drove this vehicle without a hitch through all the obstacle courses, and it was an amazing experience. You really should have seen this huge smile on their face. You're probably going to see on the screen over here. It was an amazing experience. So in the following summer, 2009, we brought our vehicle to the University of Maryland campus. They had an event called Youth Slam, and we invited dozens of blind students from all over the country, and trained them and let them feel the freedom and independence by letting them drive the vehicle. And this video clip is a 16-year-old completely blind student being trained and riding the vehicle for the first time.
Press the brake. All right, so you're good?
Yep.
So this is your test. This is your pre-driving test. And you just passed. So there you go. Congratulations. All right, so what we're going to do now is put the headset on you. So you can hear the instructions pretty well. It's loud enough.
Mood?
Hold. So we're ready to start moving.
Okay.
Yeah, great. So we'll keep that center now here to start. And we'll just start you on the left steering just to keep you on the right track. So you'll keep your left foot on the brake. And your right hand I'll put on the ignition. Left here. Turn that clockwise, so pull it to like that. Perfect. Start it, hold your left on the brake. If we can have everybody clear out of the front, please, for safety. People get excited to keep getting up. Alright, so when you're ready, go to left foot, put your left foot off the brake. Slowly press the gas. That's it.
Cool.
You did awesome.
She's a better driver than myself. So, isn't it amazing? But how does it work? Well, we don't have a lot of time, and it's a very complex system, so we don't have time to explain everything. Let me try to simplify it to explain how it works. So step one, what you do is the driver punches in the destination where we're going to go. It's just like the navigation system in your car. So you tell the computer where you want to go, and the computer decides the best route to get there. Now, that's the first step. The most important part is perception. So obviously the driver cannot see. So how do you figure out where you are in the road? How do you figure out where the roads are? How do you figure out where the obstacles are? So we use different type of sensors for the perception. Now first we use a GPS. Now again, this GPS is similar to the GPS that you use in your navigation system. The GPS talks to the satellites in space and tries to figure out this location in the world. But this is not good enough. It's not accurate enough. So we also use a thing called IMU, initial measurement unit. So these are accelerometers, and we try to measure the acceleration of the XYZ and the angular acceleration, the general motion of the vehicle, to pinpoint our location on the road. So this is how we know our location. Now, we also use cameras. So we have two cameras mounted in the windshield, and they look forward and a little bit down, so we can figure out detect the lanes of the road. What about obstacles? For those, we use these special sensors called LiDARs, or the laser rangefinders. So how this works is, it shoots out a laser beam and it scans through. And if the laser beam hits an obstacle, then it bounces back. And it measures the time of the flight of the laser beam. So we know the speed of the light, and we measure the time, then we can measure the distance. And that way we can make a map around the vehicle. So we have two LiDARs facing forward, and one in the back. So we can figure out the cars in the back and the force, or any obstacles that jump into the road. So these are the sensors that we use for perception. So all this vast amount of data is transmitted to the computer. So this is navigation. So the navigation computer does two things. One has to do with information. One has to do with instructions. So with this vast amount of information, we have sophisticated computer algorithm that the computer tries to figure out. It classifies this object. Oh, that's a car over there. Oh, that's a person. That's a tree. These are the lanes of the road. So we send these informational cues to the driver so the driver can figure out. I'm going to talk about how we do that. However, another thing it does is instructional cues. So the computer is smart enough, so it tries to figure out the safest way to drive, and it figures out what's the steering wheel angle and the gas and the brake pedal, and those instructions are also sent to the driver. Now the problem is this: information cues, instructional cues, that's good, but how do we send this to the driver who cannot see? So this is where the non-visual user interfaces come into play. Now, we developed many different types of non-visual user interfaces, but I'm going to just talk about 3 of them today. So one interface is called the drive grip. It's like a glove that you put on your hand, and we have tiny vibrating motors on the back of the hand. So when the computer sends signals of how to turn the steering wheel, these motors vibrate, so you can do 좌회전, 우회전, go fast or slow, turn more. So that's how we send signals to the driver. Another user interface we came up with is called speed strip. So that thing that you see over there, it looks like a massage chair, right? Actually, it is a massage chair. So we bought these massage chairs, open up, and we take out these vibrating elements, and we experiment with different type of patterns on the back. And then this is how we send another type of information to the user. We mainly use it for speed, but we can use it for different things. It can tell you to slow down, go faster, or it can also indicate the current speed. So in the picture, you can see the speed strip installed and also a pair of the drive grip gloves. And you can also see our safety e-stop, emergency stop, because safety is so important. Now, the drive grip and the speed strip, these we call instructional cue user interfaces. In other words, these are used for the computer to tell the driver how to drive. It tells you the instructions: turn left, turn right, go faster, go slow. However, this is not the real thing that we want to do. We call this the backseat driver problem. Somebody in the back telling you how to drive. This is not really freedom. So we're now moving into the next generation of the non-visual user interface devices. One good example is AirPix. So AirPix, you can think of it as a monitor, computer monitor for the blind, but obviously the person cannot see. So this is a tablet with a lot of holes in it, and compressed air shoots out of these holes, so it can display images, so the person can see. There's a tree, there's the road, there's a kid over there, there's a car. So the person can get this information, so the driver can make active decisions and drive, and that is the AirPix. As I mentioned, besides these, we came up with many different type of non-visual user interfaces: tactile shoe, leg strap that uses pressure, 3-dimensional spatial sound system with pinging sounds, click wheel with audio cues and all those kind of things. But one thing that we learned is more information for driving is not necessarily better. We call this the information sensory overload. So we're still trying to do research and figure out what's the optimum configuration, a combination of these interfaces and the right amount of data that we transfer to the user. All right, so we have these non-visual user interfaces, and we give that to the driver, and the driver simply drives the car. The car is a regular car. It has a steering wheel, you have the accelerator and the brake, and the person drives, and that's how it works. So another vehicle that we developed is called Vivian, Visually Impaired Vehicle Interfaces for Advanced Navigation. It's a really ugly golf cart, but this was more of a test platform. As I mentioned, we tried to figure out the right combination of user interfaces, so we mount different things, test different things, and different configurations. Now, one secret to our success is that we worked with the blind. We had blind engineers working with us. Now we have a blind student officially in our team. We travel, we go visit different type of schools for the blind. We have open discussions, we have brainstorming sessions. We invite blind people to drive the car, and we get feedback. And we improve the vehicle. And that is very important. We also spend a couple of days at the headquarters of NFB, National Federation of Blind. We live with the blind, sleep, eat together, and we learn what it's really like to be blind. And all of these things really help developing technology. So, as you can see, This has been a huge story. It's been on BBC from England, CCTV from China, CBS Morning Show, CNN on TV. It's been on multiple newspapers. You see it was on the front page of Washington Post. Multiple magazines, Wired, Popular Science, Popular Mechanics, cover of magazines. It's been a huge media frenzy. Now, I don't know if this is a good thing or a bad thing, but our project was also on Ripley's Believe It or Not. 믿거나 말거나 말이죠. So, where do we go from here? So, we have succeeded developing a car for the blind, David. However, this vehicle was never really meant to go on the real roads. This was designed as was a feasibility study to see if it's even possible. It's designed to go on the parking lot. Even the roads were, defined by red traffic cones. So now, we're taking the next step. We are building the next generation blind driver challenge vehicles. It's called Brian and Andrea. This time, it's a real car. And this is going to be tested on the real roads driven by a blind person. And I'm also very happy to announce that we will have our very first public demonstration in January 29, 2011. There's a very famous racetrack called the Daytona International Speedway in Florida. And during the very famous racing event, Rolex 24, we are going to demonstrate this vehicle. A blind person is going to be driving it. And we're planning some really spectacular demonstrations, but I'm not going to tell anything because I don't want to spoil the surprise. So you're going to be hearing and seeing a lot of this early next year. So, it's been a huge success. And I'm literally getting hundreds and thousands of mail, phone calls, letters from people from all around the world. Most of them are saying, oh, thank you so much. You can't imagine how much hope you're bringing to the blind. Using technology for the blind, this is fantastic. Thank you so much. Oh, I would like to volunteer. I would like to help out. From sighted people, blind people. We also get very touching letters. A lady from Belgium, she's blind, but she's also on a wheelchair. Can you use these technology for my wheelchair? A farmer from Iowa said, I'm a blind farmer. Can you use these technologies for his farming equipment? Sometimes I get some funny letters. This is a letter from a person from California, and he said, now I know why there's Braille on a drive-up ATM machine. But sometimes we get letters which is not really, that positive. I wouldn't call it hate mail, but they say, Dr. Hong, are you insane? You must be out of your mind trying to put a blind person on a car driving next to me. Not acceptable. Well, if you think about it, it sort of makes sense. Safety is paramount. Safety is a very important thing. But I would like to also tell you that this vehicle is a research prototype. It's not going to be on the road until it's proven safe. Now, what do you mean by proven safe? As safe as or safer than today's vehicle for the sighted people. Now, the good thing is, I truly believe that will happen in the very near future. They also say technology fails. What if the system drive grip doesn't work? It's going to crash. I don't want it to crash into my car. Yes, but again, last time you flew in an airplane, you probably didn't doubt about the autopilot that's probably controlling the airplane either. So, the immediate goal for this project, of course, is to develop a car for the blind, to give them freedom and independence. But there's something more important, more bigger than just that. It's the potential of the spin-off technologies, the technologies that we're going to develop through this project. For example, the technology that we develop can benefit not only the blind, but also the sighted people. Good example would be safer cars for the future. Those laser rangefinders that we use that I talked about? They can see through the rain, the fog, through the night. So, lane departure systems, even nowadays some high-end cars has these lane departure systems or auto parking. So these technology will be used for future cars to develop safer cars. The next car that you buy might have some of the component technology that we have developed. But what about the blind people? Of course, besides driving, we can use these for everyday home appliances. One good example might be in the classroom. The teacher writes on the blackboard. Blind students cannot see, but simply scans it, sends the information to this AirPix device, and the blind people can actually see and read what the teacher writes on the blackboard. Valuable. Very, very important spin-off technologies. But is the world really ready for this technology? Social acceptance. Well, I truly believe, besides technological problems, there's also other social infrastructure problems. For example, how are we going to issue driver's license, 운전면허증, for the blind? Right? How are we going to cover insurance for the cars? There's a lot of other problems that we need to solve before this becomes a real product. So I always tell people that the technology will be ready before the society will be ready. So at our lab, the ROMELA, the Robotics and Mechanisms Lab, we developed many, many different type of fascinating robotics projects. So this Blind Door Challenge project is something really different from the others. You've probably seen or heard some of our robots. Raphael, the robotic hand that uses pneumatics. It's for prosthesis applications, for those to help those who lost their hand. And the best part is, it's a very low-cost solution, only $200 to make. Another robot called Hydrus is a snake robot that climbs structures, climbs scaffoldings in the construction site. Every year, hundreds of people get killed and get injured by falling down these type of structures. So if it's dangerous, we send the robots instead. Another robot called Impasse is a ultra-high mobility robot that can go over rubble. So for search and rescue missions, we send these robots to save people's lives. Another famous robot is Charlie, the United States' very first full-size humanoid, autonomous humanoid robot. This can be used for your, it might be living in the future in your home, doing the dishes, folding the laundry for you, cleaning up the house, or taking care of the elderly. Well, that's me. I'm not that old, but you get the idea. Of course, the Blind Door Challenge vehicle. So if you think about all these kind of things, there's a common theme to what we're trying to do here. What we're doing here is trying to develop technology to help people, to help society. And that is the key. That is the most important. So whenever we have new students come to our lab, and when they start working on this Blind Door project, I always ask them the question, how many times in your lifetime do you think you have an opportunity to really change the world? I truly believe we're doing that with this project. So, students, teachers, scientists and engineers, please join us in developing new technology for the blind, and let's change the world together. Thank you very much.